Okay guys, so today we're talking about writing equations when we're starting with a word problem. So what we're going to do is we're going to look at the following word problems. We're going to write an equation and then we're going to solve it. So the first couple are really basic, and what I like to think about it as is think about translating from English to math. So the first one is 5 more than a number is 12. So if I'm going to translate that into mathematics or translate that into an equation, well, 5 is just 5. That's pretty easy. And then think of more than. What does more than mean mathematically? Well, more than means plus. So we have 5 more than is 5 plus, and then a number. Whenever we see like a number or an unknown, that's when we need a variable. So that's when we need to pick a letter or a symbol to represent that unknown. Some number. 5 more than some number is 12. So in this case, I'm going to pick x. Really doesn't matter what you pick. Is 12. So is in this case is going to mean equals. So 5 more than a number is 12 or equals 12. And that's what our equation is. 5 plus x equals 12. So we can use that equation to solve and find out what that number is. So get x by itself. So our first step there is to subtract 5 from both sides. And we get x equals 7. So that tells us if 5 more than a number is 12, then that number is 7. So let's try another one. 3 less than twice a number is negative 8. So 3 less, if we're going 3 less than something, like 3 less than 10 is 7, and 3 less than 5 is 2, what are we doing? We're actually subtracting 3. To find 3 less of something, we're subtracting 3. And then twice a number. So twice a number, if you want to know what twice a number is, you're going to multiply that number, that unknown, so we'll use x, we're going to multiply that x by 2. So 3 less than twice a number is, or equals, negative 8. So we've got things kind of mixed up here because we have the minus 3 and we have the 2x, but we don't really know how they go together. So we're just going to throw the minus 3 on the other side. So we have the twice a number, and then we're going to do 3 less than that, so we're going to subtract 3. So 3 less than twice a number would be 2x minus 3 equals negative 8. So that's the equation. So now we solve that to figure out what that number is. So to solve that, we add 3 to both sides, and we get 2x equals negative 5, and then we divide both sides by 2, and we get x equals negative 2.5. So if 3 less than twice a number is negative 8, that number is negative 2.5. Okay. All right, so the next one, a number increased by 12 gives the same result as twice the number. So again, we have a number, but we have it there twice. We have a number at the beginning of the sentence, and we have twice the number at the end of the sentence. So keep that in mind. So a number increased by 12. So we have some number, we can use n. Like I said, it doesn't matter what variable you use. Increased by. So when I think of I'm increasing something, I'm adding to it. So a number n increased by, so plus 12. Then we have gives the same result as. So that's a whole lot of words. Gives the same result as, that just means equals. And then we have twice the number. So we saw that in the last problem. Twice the number means we take the number and multiply it by 2. But what number? The same number we saw back at the start of the sentence. So we have some number increased by 12 gives the same result as twice that number. So 2n, we're going to use the same variable. So our equation is n plus 12 equals 2n. So that's one of those problems where we have the same variable on either sides of the equal sign. So the first thing we have to do to solve that is get that number on the same side. So in this case, we're going to subtract n from both sides to collect our n's or put them together. but 2n minus 1n is just n, so we end up with 12 equals n. So the number is 12. So a number increased by 12, so that would be 12 plus 12 would be 24, is the same as twice that number. So 12 times 2 is also 24. So that totally makes sense. So those are very basic, straightforward questions. D takes a real-world example and asks us to do the same thing. So Andrew has $145 and he decides that he will save $7 a week. When will he have saved $236? So let's think about his situation. He starts with $145 in his bank account. And to that, every week he adds $7. So we'll say, $7 each week. So the first week he would have saved $7. The second week he would have saved 14, 21. So we're going to do 7 times the number of weeks he's saving, because if he saves for 1 week, it would be 7 times 1. 2 weeks, it would be 7 times 2. 3 weeks, 7 times 3. So we'll say 7W. So he starts with $145, and every week he's adding $7. So we'll say 145 plus 7 times the number of weeks. So we want to know, if we go through that, so the first week it would be 145 plus 7 times 1, and then the second week 145 plus 7 times 2. When will that amount equal $236? So when we write our equation, we say the 145 that he has in the bank account plus the $7 per week equals $236. So to solve that, we subtract 145 from both sides, and then we divide both sides by 7, and we get 13. So Andrew will have saved $236 after 13 weeks. Okay? Okay, so the sum of two numbers is 56. The first number is 18 more than the second number. Find the numbers. So this one's tricky because we're looking for two different numbers. All the problems before this, we were only looking for one value or one number. So we only needed one variable to represent one number, and we solved for it and it was fine. Now we have two numbers that we're looking for. The problem is we still only know how to solve an equation with one variable in it. So I can't write an equation using two different letters to represent the two different numbers because I don't know how to solve it. So the idea is that we have the first number plus the second number equals 56, and they're two different numbers. The first number is 18 more than the second number, so we'll use a letter, in this case n, to represent the first number. So the second number, I can't just use a totally different letter because I don't know how to solve that equation. So I have to use n or some form of n. So I know that the first number is 18 more than the second number. So if I took the first number and subtracted 18 from it, I would get the second number. So whatever the first number is, if I subtract 18, I get the second number. So n take away 18 will give me the second number. So then I can write my equation. The first number n plus the second number n minus 18 will give me 56. Before I solve this, I should combine my like terms. So n plus n is 2n. And then I can go ahead and solve. So I'm going to add 18 to both sides. And I'm left with 2n equals 74. And then divide by 2. And I get n equals 37. So that tells me the first number is 37, but it doesn't tell me the second number. But remember, the second number is 18 less than the first number, so all I have to do is 37 minus 18, and it tells me the second number is 19. So the first number is 37, the second number is 18 less, which is 19. And you can test it. 37 plus 19 is 56. and 19 is 18 less than 37. So it totally works. Okay, so this example is similar to the last one in that we're looking for more than one number. In this case, we're looking for 3. And again, we can't just use 3 different variables because we don't know how to solve that problem. So this one says the sum of 3 consecutive numbers is 72, find the numbers. We need to use one variable to write this problem. So we have to look at the term consecutive. And what does consecutive mean? So consecutive numbers are numbers that count in a row. So for example, 3, 4, 5, or 72, 73, 74, or 15, 16, 17. So those are consecutive numbers. So we need to find 3 consecutive numbers that when we add them up, we get 72. So how do we write consecutive numbers using only one variable? Well, if we say the first number is A, then the next number is just one more than that because consecutive numbers were just going up by 1 each time. So if the first number is A, the second number would just be A plus 1. And the third number is just one more than that, so it would be A plus 2. And that's how we write consecutive numbers. So that's something that you can kind of store in your brain for the future. Whenever you're thinking of consecutive numbers and you're trying to write variables to represent consecutive numbers, you just pick a variable for the first number. The next number is plus 1, and then plus 2, and plus 3, and plus 4. So store that somewhere in there that you can grab it when you need it. So the problem says the sum of these 3 numbers. So we have to add up these 3 numbers. The first number plus the second number plus the third number is going to give us 72. So that equation is going to be A, which is the first number, plus A plus 1, which is the second number, plus A plus 2, which is the third number, is 72. So before we do anything, we should collect our like terms. So A plus A plus A would be 3A. And our constants, which is 1 plus 2, which would be 3. So our equation would be 3A plus 3 equals 72. So to solve this, we subtract 3 from both sides. 3A equals 69, and then we divide both sides by 3 and get A equals 23. So remember, we always have to read the question. It doesn't just want the first number, it wants us to find all the numbers. But the great thing about this is they're consecutive numbers. If 23 is the first one, the other two would just be 24 and 25. So the numbers are 23, 24, and 25. They're 3 consecutive numbers that add up to 72. Okay. And the very last one, the length of a right triangle is twice its width. If the perimeter is 48 meters, what are the dimensions? So let's draw the triangle. Okay. So there's the width of the triangle. We know the length is double the width. We can't use L and W again because we don't know how to solve problems with 2 different variables. So we know the length is 2 times the width or twice the width. So instead of writing L, we can write 2W. Or 2 times the width. So we know perimeter is just adding up all the sides. So we would do 2W plus 2W plus W plus W for a total of 6W when we combine our like terms. But we don't just want an equation for perimeter of the rectangle. We want to know what are the dimensions when the perimeter is 48. So we're going to fill in 48 for the perimeter equals 6W. So then this is really simple to solve. We divide 6 on both sides, and we get that the width is 8. So the width of the rectangle is 8, but remember the question asks not just for the width, but for the dimensions. So we have to give the length as well. But since the length is just twice the width, well, 2 times 8 is 16. So the width of the rectangle is 8, the length is 16. And that's it. So those are some examples of solving word problems using solving equations. Every word problem is a little bit different, so it's all in the practice. The more you practice this, the better you'll get at it.